to give the name for these compounds. How can we do the nomenclature of these carbonyl compounds? Means the compounds containing carbonyl group. Okay, so for carboxylic acid, for aldehydes, for ketones, we have different methods for naming. We have different suffixes and prefixes. Understood? See here, first one. Listen. The common names of the aldehydes are derived from carboxylic acid by replacing IC of the carboxylic acid with aldehyde. See, first I will give you the overall concept regarding this nomenclature. See, in case of aldehydes, before that, if a compound is containing a functional group, in all the compounds containing the functional group, the name will end with, means we have to cut the E from alkane. Suppose if the compound contains only single bond, they are not containing any double bond, only single bond. So we have to remove the E from alkane. Then what you have to do? Instead of this E, we have to add some suffixes. Means for aldehyde, it is one name. For ketones, it is other one. And for acid, it is another one. Okay. So if it is an aldehyde, what you have to do? It will be alkan plus Al, alkanal. For aldehydes, the name IUPAC nomenclature I am telling. Understood? So the IUPAC nomenclature of the aldehydes will end with Al. So it will be alkanal, like that. Okay. Then one more thing is, the aldehyde group will always come at the end of the chain. Because one group is hydrogen. In the carbonyl group, one end is hydrogen. This one, right? So always this group will come at the end of the chain. So no need to give the number because it is always 1. In organic chemistry, in nomenclature, the number 1 we are not usually mentioning. Other numbers 2, 3, these numbers we only mention. If it is 1, we don't mention that number. Got it? So what you have to do? No need to write the number. Just check the number of carbon atom in the chain. Then write in the form of alkan. Then add Al. See, I will give you an example. Suppose I am writing a compound CH3CHO. See, this is the aldehyde group, right? Then how will you name this one? How many carbon atoms are there? In case of aldehydes, if you are giving name for these aldehydes, we have to count the carbon atom present in the aldehyde group also. So how many carbon atoms are here? 1, 2. 2 carbon atom. So if it is 2 carbon, how will you name this compound? It is 2 carbon, we know it is ethane. If it is an alkane, normal alkane, we will call it as ethane or ethane. So what you have to do? Just remove E from ethane. So ETHANE is the name. I am removing E, then I am adding Al. So this is ethanol. The name of this compound is ethanol. If it is 3 carbon, it will be propanol. If it is 4, butanol. Like no need to mention the number because CHO group, the aldehyde group will be always at the end of the chain. Got it? Understood, right? See, acetaldehyde. This acetaldehyde is the common name for ethanol. But the IUPAC name is ethanol itself. Okay, then this one is benzaldehyde. Why it is benzaldehyde? In benzene, one hydrogen atom is replaced by this aldehyde group. Then here you see, this is beta bromo butyraldehyde. Why beta bromo? Because other than this CHO group, there is one more functional group, that is bromo group, bromine atom. Okay, next one. Ketones gets their name, common name from 2 alkyl aryl groups bonded to the carbonyl group. The substance means, see, in case of ketone, the same thing we are doing in case of ketone. But the thing is, what you have to do, it will be like alkan plus one. It will be like this. But the thing is, in ketones, the CO group will be always at the middle of the chain. It won't be at the end. Because both the group connected to the carbon atoms are alkyl group. See, one example I will give you. CH3, C double bond O, CH3. How many carbon atoms are here? 1, 2, 3. So normally 3 carbon atoms we will call it as propane. Okay, so what you have to do? Remove E and add ONE. So it will be propanone. Propanone. But here the CO group is there. But if the 3 carbon atoms are there, the only one possibility is CO group will be at the middle. So no need to mention the number 2. It will be simply, we can say it as propanol. Okay, that's all. That's all about the nomenclature of ketone. Then what about the nomenclature? See, the same rules they are explaining. Aldehydes and ketones, open chain aliphatic compounds are named by removing E with on and al. Al for aldehyde, on for ketone. The longest carbon chain in the aldehyde numbering, I told you, because we have to count the number. If it is 3, it will be propan. If it is 4, butan. If it is 5, pentan, like that. Okay, see here. Pend to enal. Why it is like that? Because here the second carbon, the priority is going for this group and the second carbon have a double bond. So it will be pend to enal. Got it? So the same way we have to name this compound. Okay. Then next one, how will you name these? Carboxylic acid. How can you give name for the carboxylic acid? The same thing. Okay, the same thing we have to do, but the difference is it will be alkane plus remove E and add oic acid. One more thing is the carboxylic group, that is COOH group, right? COOH group is always comes at the end of the chain. Why? Because see this one, it will be here. Got it? So it will be suppose, so we have to count this carbon also. So one example, CH3, CH2, COOH. How many carbon atoms are there? 1, 2, 3. So it will be propan. Normally it is propane. I am removing E and adding oic acid. So the name is propanoic acid. Like that. Okay, that is the naming of carboxylic acids. Structure of the carbonyl group in aldehydes and ketones. So in both in aldehydes and ketones, we know there is carbonyl group, right? Then what is the structure of this group? Okay, see, listen, this is very important. What is the structure of this group? Important. See, the carbon atom of the carbonyl group is sp2 hybridized. As I told you in the previous classes, see what I told you. If the carbon is connected to a double bond, if the carbon atom contains some double bond, the hybridization of the carbon should be sp2. So in the case of carbonyl compounds, the carbon have double bond with oxygen, right? Whatever it may be, if it is aldehyde, ketone or carboxylic acid, whatever it may be, it is always doubly bonded to oxygen. So what will be the hybridization of this carbon? It will be sp2 because this carbon contains some double bond. So the hybridization is sp2. Okay, the 4th valence electron of the carbon atom exists in the p orbital and forms a pi bond with oxygen by overlapping with the p orbital of oxygen. See the same thing. How this pi bond is forming? We know sigma bond and 2 types of bondings are there, right? Sigma bond and pi bond. How the sigma bond is forming? It is by the end-on-end overlapping, or we can say it is head-on-head overlapping. Pi bond is formed by the sidewise overlapping, right? One p orbital will be like this one. See, this is the one p orbital. Then another one. This is called a pi bond. This is sidewise overlapping. This is the overlapping area. These type of overlapping will lead to the formation of pi bond. Then what is sigma bond? This end-on-end overlapping like this. This is sigma bond. Got it? So here the pi orbital of the carbon atom means the p orbital of the carbon atom will overlap with the p orbital of the oxygen atom. It will be like this sidewise overlapping. That's why this one bond is pi bond, other bond is sigma bond. Got it? The oxygen atom consists of 2 bonding electron pairs. We know that one. The 3 atoms of the carbonyl group lies in the same plane and the pi electron clouds lies above and below the plane. The same thing I told you, because if the overlapping is sidewise, what will happen? See, in head-on-head overlapping, see, the overlapping area should contain the electrons. But in case of sigma bond, the head-on-head overlapping means only one overlapping area is there. So electron density will be concentrated on this area only. Then what about this pi bond? In pi bonding, we have 2 overlapping area. One is above the plane. See, suppose if you are drawing a middle line here, see, this is one area of overlapping. This one is the second area of overlapping. So one area is above the plane, other one is below the plane. And the bond angle will be 120 degree. It is called a trigonal planar. Okay, then the same thing we discussed in the last class. See, high electronegativity of oxygen makes the carbon-oxygen bond polarized. Same thing. See, in case of carbonyl group, C double bonded to oxygen, and other two groups may be whatever it may be, leave it. But what will happen? If you are comparing the electronegativity of carbon and oxygen, oxygen is more electronegative than carbon, we know. So this carbon will get a partial negative charge. Oxygen will get a partial negative charge, carbon will get a partial positive charge. Why? Because oxygen have high electronegativity. Oxygen can attract the shared pair of electron more than that of the carbon atom. So electron density will more concentrate on oxygen atom, less on carbon atom. So oxygen will have a partial negative charge, carbon will have a partial positive charge. Okay. Then the high polarity of the carbonyl group is due to the, I told you, see how this is polarity due to this electronegativity difference. Got it? Yes.